Why do we look the way we look? Most of it's down to dear old planet Earth. Its atmosphere, gravity, that kind of stuff. When you go on a week-long beach getaway, you get a tan. Basic. But what about living on a whole other planet? One astronaut spent a whole year living on the International Space Station. Zero gravity means no healthy pressure on your body, so his bones got weaker. So did his muscles. It also gave him more space between his vertebrae, so he got a bit taller. And that's only a year. The more time you spend at the beach, the darker your tan gets. So, what if we move to Mars? The first major change you might notice, after a couple hundred years, is your brand new skeleton. Gravity on Mars is much lower than on Earth, so your muscles and bones would probably shrink. Not great for surviving on a new planet. Gravity would make us feel our weight differently. If you weighed 150 pounds on Earth, you'd only feel like you weighed about 50 pounds on Mars. You'd need to eat more to get stronger and bigger to make up for Mars's weak gravity. Sweet! Time to grow some larger and stronger bones, organs, muscles, everything. There'd be one more dramatic change. Your largest organ, your skin. It's the most important barrier that protects you from everything. Germs, wind, UV light, looking totally creepy, you name it, it does it. You might just need a whole new skin. How do you feel about orange? Sorry people, green skin is totally sci-fi. Here's the deal. Carotenoids offer quite a nice protection against UV light. That's the stuff you find in carrots, sweet potatoes, bell peppers, tomatoes, pumpkins. A Mars farmer's market could make a fortune. The more of these veggies you eat, the more orange your skin's gonna get. If you followed a special diet and wore high-tech gear, chances are, one day, living on Mars might be totally normal. Living on Mercury would be really tough. It's the closest planet to the Sun, and it's definitely hotter than Earth, but weirdly, not hotter than Venus. It's really hot during the day, about 800 degrees, but at night, it drops to -290. Days on Mercury are kind of crazy. You know, when you finish the day, but you didn't really get a lot done? Problem solved. Move to Mercury. A day on this planet lasts about 58 Earth days. That means you'd have a lot of time to get ready for bed. My guess, though, you'd probably get kind of bored. One excellent solution. Somehow, become made of metal, like titanium, nickel, or platinum. Those guys can handle extreme conditions. Life on Venus would be way worse than Mercury or Mars. Pressure might be a tiny issue. You'd probably have one long, never-ending headache. Standing on Venus is like being 3,000 feet underwater. Oh, and that thing we need every moment of the day? Chocolate. Air? There's not a lot of that floating around on Venus. There's carbon dioxide everywhere, and the planet's surface is completely dry. That means it's gonna be hot. 870 degrees hot. There are a few species on Earth that can survive the boiling point of water, and maybe if they mutated somehow, they'd survive Venus's crazy heat. 266 degrees is the record so far, set by a species of microbes. So get ready for an epic body transformation. Want to live on Venus? You'd probably have to turn into a tiny microbe just to survive. Luckily, Venus's atmosphere has phosphine, which isn't great for humans, but microbes just love it. But since you're not a microbe, not yet anyway, you'd need to wear special gear to control the pressure and feed you air. It's not looking good. Maybe it'd be easier on Jupiter. Yeah! No. It's got no solid land. This planet's made of hydrogen and helium and is known as a gas giant. Unlike Saturn, you'd probably end up just floating around on it. It's like a giant cloud, and if you ever managed to land, it'd be like walking through a super thick fog. Temperatures fluctuate a lot here. It's freezing on the surface, and the atmosphere can be super hot below the surface. We don't really even know. If you lived on Jupiter, there'd be no spoken languages. The gas planet absorbs radio waves, so even if you could speak, no one would hear you anyway. And there'd be no music, so no dance parties. What's the point? People would have to communicate in sign language. Great! But it's not. The atmosphere on Jupiter is wild. All kinds of winds and gas clouds. You probably wouldn't even be able to see anything. So that's not gonna happen. Still, Jupiter is awesome to look at. It's so big that it can fit all the other planets in our solar system inside it, with room to spare. A trip to Saturn will set you back about a decade, and it'd be a big old waste of time. Saturn's mostly made up of layers of gas. It has no solid surface, so farming, building, or any other normal Earth activities are out of the question. Before landing on Saturn itself, you'd probably want to explore those iconic rings around it. You'd fail though, because the rings are made of millions of ice sprinkles floating in space. That's pretty hard to walk on. You might have thought that Saturn was going to be a good fit for you. Some layers of this gas giant sphere actually have quite a nice temperature. If you dive into Saturn, you'll get to a layer with liquid molecules and a cool 32 degrees. That's like northern Canada, Alaska, Sweden, except that you can't walk on it. Anyway, it's only one minor layer, and the rest of the planet is insanely cold. So I guess if you still want to live on Saturn, you've got some work to do. No biggie, you just gotta turn into a snowball or something. What about Uranus? Time is kinda weird on Uranus, so if you're out that way looking for a nice vacation spot, definitely choose this planet. A 2-week getaway on Earth lasts 3 years on Uranus. There's even a sea if you're up for a beach vacation. The only problem is that it's made of ammonia, that gross-smelling stuff they use for cleaning. But watch out where you land. If you get it wrong, you might end up spending a whole year without any sun. How would you change if you had to spend a whole year in the freezing dark Uranus winter? We'd need bigger eyes to see in the dark, plus more of that thicker skin to keep the cold out. We might even develop a new hearing system, like dolphins have. Neptune. It's another gas planet, but scientists think there's probably a dense core inside. If you took the plunge to live on Neptune, you'd probably turn into a space reptile or cosmic fish, endlessly floating around on the surface. Gravity on Neptune is just a little bit stronger than on Earth. Still, it'd be really hard to stay in one place. The wind there is super strong. You'd have to be much heavier to resist it. Time to eat again, woohoo! But this planet's really impossible to live on. Scientists don't even want to send another spacecraft there. Welcome to Pluto. Freezing cold, tiny, and super far away. Doesn't sound too exciting. It's even smaller than our moon. It would be so hard to stay on the planet. No more trampoline parks, people. You'd probably have to build yourself a huge machine that would spin you around, sort of a fake gravity machine. Still, you try spinning around all day, you'd need a brand new nervous system to avoid feeling queasy all the time. But Pluto's not all bad. There's a liquid water ocean beneath the surface, and ice mountains. If you got yourself a highly trained crew and a bunch of expensive gear, and regular supplies from Earth. Nah, too much hassle. Spaghettification. Wonder if you can choose your own sauce? It's actually something you might experience if you ever tried to live in a black hole. It's the process of squeezing objects, like you, into long, thin cosmic strips. So, good news, you'll get much taller. Bad news, you'll be thinner than a single human hair.
A wanderer, walking through a desert, feels the scorching sun like never before. You can see him from afar thanks to his shining clothes. His long hoodie is covered with foil. It reflects sunlight and protects him from heat. The ground is so hot that shoe soles can melt on it. That's why the wanderer's boots are covered with heat-resistant material. A cloudless sky, barren land, and heat. But the wanderer is not in the desert. He's walking on the ocean's bottom. He doesn't know why this happened, but all the oceans on Earth dried up. It happened almost instantly, and even the greatest minds in the world don't know why. The Wanderer knows only one thing. When it happened, his family was on the other side of the ocean. For several months, he's been traveling across this lifeless land, and he won't stop until he finds his family. The landscape around is spectacular. People have finally found out the secrets of the ocean depths. The seabed consists of huge mountain ranges and volcanoes. They fell asleep forever after the water had disappeared. Also, there are huge trenches leading to the unexplored depths of the planet. People had to build bridges to get over these enormous cracks in the ground. But most of the ocean floor is flat plains, boundless, lifeless, merciless. The Wanderer's walking across a huge canyon. Once, it was swarming with sea life. The man puts on a gas mask, but not because of a sandstorm. Many fish and other marine inhabitants used to live in such canyons. Now, all that's left is a terrible smell. The Wanderer passes by huge skeletons of whales. Among them, he notices dirty tents. People are hiding there from heat. The temperature in the area is much higher than in the Sahara Desert. One of the main functions of the ocean was to distribute heat all over the planet. The sun emits heat and radiation. The ocean absorbed this energy. Lots of currents were warm, and they carried this warmth around the world. The water got heated at the equator, then it evaporated and turned into clouds. When warm air rose, it pulled along colder air from below. This allowed the energy to be evenly distributed. In simple words, the ocean cooled hot places and brought warmth to cold ones. Now there's none of this. Every day the sun burns the equator and dries up the rest of the planet. The Wanderer doesn't come close to the tents. He is carrying the most valuable treasure in the world and doesn't want people to notice him. The inhabitants of Earth are just trying to survive, and many have forgotten about such a thing as morality. Fortunately, the Wanderer still remembers. The thoughts of the family help him remain a good person. Sometimes it complicates his life. Like now, for example. In the distance, he sees a young girl. She doesn't look well. There's no one around, and the Wanderer decides to help her. Out of his backpack, he pulls a thing worth more than all the gold on the planet, a bottle of water. The girl takes a few sips, but instead of thanking the Wanderer, she starts screaming. It's a trap! Her accomplices appear from different sides. Looters. They're gonna take everything. The Wanderer runs away. He hasn't eaten for several days, and his strength is leaving him. He won't be able to keep going much longer. The marauders are closing in on him. The Wanderer throws the bottle aside. His pursuers rush to the water like crazy. They forget about the man and fight one another for the bottle. The chances of the Wanderer's survival have greatly decreased. He could make this bottle last at least several days. Plus, he's also lost a lot of fluid because of running. In the beginning, there was no panic because of a lack of water. The ocean dried up, but its waters were salty anyway. People still had seas, lakes, and rivers. But the problem was that the ocean was feeding them. When the ocean water evaporated, it formed clouds. These clouds moved all over the world and enriched lakes and rivers with rain. Now, there are almost no clouds. The sun started heating Earth much more. Lakes and seas dried up alarmingly quickly. At that moment, real chaos began. The sun is going down on the horizon. Sunset is near. It's not so hot anymore. The exhausted Wanderer continues walking. In the distance, he notices something that makes him stop, take out a small shovel, and start digging quickly. There's no shelter around, just a flat plain. The Wanderer speeds up, otherwise it might be too late. The pit is finally ready. The man jumps down and covers his head with a cloak. A few seconds later, a strong ash storm passes through the entire plain. The smallest particles of ash can penetrate through clothes and get into the lungs. The wind is so strong that it can knock anyone down. When the oceans dried up, the sun began to burn the surface of the planet. This led to massive forest fires. The flames destroyed almost all the trees. Huge clouds of carbon dioxide and ash formed. Driven by the wind, they travel the world and poison everything around. The Wanderer is sitting in the pit while a terrible hurricane is sweeping over his head. He thinks of his family and slowly falls asleep. Cold wakes him up. Frosty air chills him to the bone. So it's night now. The wanderer climbs out of the pit and finds himself under bright stars. As soon as the water dried up, almost all clouds disappeared. Factories stopped working. Cars no longer emitted carbon dioxide. Thanks to this, comets and the most distant stars can be seen in the sky. The wanderer has seen them 1,000 times, but he's still not used to the breathtaking picture. It's like he's looking at the sky through a telescope. An icy gust of wind brings the wanderer back to reality. He won't survive the night if he doesn't find a warmer place. Before, nights were warmer thanks to the energy of the ocean. Now, as soon as the sun goes down, temperatures drop dramatically. The wanderer needs to move to stay warm. He starts walking faster. Soon, he notices some lights in the distance. It's probably other looters. The wanderer goes deeper into the valley. Stars and the moon illuminate his way. Unfortunately, he is running out of energy. He pulls a protein bar out of his pocket, but he needs at least a bit of water to eat it. To digest food, your body needs liquid. If the wanderer eats the bar, he'll only get thirstier. He can't walk and falls to the ground. He checks his pockets and finds a small kerosene tablet. He lights it using a matchstick. A tiny flame protects him from cold. To distract himself from thirst, the wanderer takes out an old MP3 player. He charged it during the day using the solar panels on his backpack. The man puts on headphones. Classical music calms him down. He lies on the ground next to the burning tablet. He needs to gain strength to continue his journey tomorrow. It's morning. In an hour, the sun will start burning the ground again. It's crucial to find water while he still has some time left. The wanderer inspects the territory and notices a spot where the ground is darker. In his previous life, the wanderer worked as a surveyor. He takes a few steps and touches the ground. It feels cool. There's an underground spring here. He begins to dig. The ground is getting wet. Water starts seeping out of the soil. The wanderer fills his empty bottles. Things don't look that bad anymore. It's getting a bit more difficult to breathe with each new day. In the past, phytoplankton and algae produced up to 70% of all the oxygen on the planet, but not anymore. Several days have passed. The wanderer runs out of water and food again. Fortunately, not for long. He's now walking among huge sunken ships. He sees modern aircraft carriers, liners, and even ancient pirate boats. In the distance, he spots huge mountains. The tops of these rocks are what used to be called the shore. The ocean floor is ending. The thoughts about reuniting with his family give him more strength. The man reaches the top and finds himself in the middle of a ruined city. It's empty. Where have all the people gone? Where is my family now? The wanderer asks himself. The man walks through the abandoned streets and meets an old man. He says that almost all the people who used to live here left the city and went to Antarctica. The wanderer has a new goal. He's going to get to the icy mainland no matter what. He will find his family.
The Moon is the Earth's closest space neighbor and its only natural satellite. It likely formed when a huge Mars-sized object crashed into our planet billions of years ago. I wasn't around then. This catastrophe turned Earth into a scorching ball of molten rock. It also pushed some material into its orbit, creating the Moon. Now, this heavily cratered sphere moves around our planet. This causes high and low tides around the globe. A bit more than 1/4 the size of Earth, it's the 5th largest natural satellite in the solar system. The Moon has several phases. For example, new, full, or crescent moon, first and last quarter. But whatever the satellite looks like, you can always find it in the night sky, and sometimes even during the day. But imagine waking up at night and noticing that the Moon looks somewhat different than usual. It seems brighter and bigger. It's hardly noticeable, especially when you're half asleep. You go back to bed, unaware that instead of the Moon, you've just seen Mercury. Close up, this planet, the nearest to the Sun, is similar to our natural satellite. Its surface is littered with craters left by space rocks. Mercury is about 2/5 the size of our planet, but it's still a bit larger than the Moon. That's why the planet would have a greater influence on Earth. Nights would become brighter, high tides would become higher, and low tides, what do you think, lower? Yup. The lunar cycle, that's the time the Moon, or rather Mercury now, needs to go through all the phases, would become 14 hours shorter. But all in all, such a replacement wouldn't have any drastic consequences for our planet. But then, how about Venus? What if, instead of the familiar satellite, we swap in the third brightest natural object after the Sun and the Moon? It's often called Earth's sister planet because their mass and size are nearly the same. Venus would be as large in our sky as Earth once appeared to the Apollo astronauts when they looked at it from the Moon's surface. The morning star would be much brighter than the Moon. For one thing, the planet reflects 6 times more sunlight. Plus, it would occupy an area at least 16 times larger. That's why nights on Earth would be as bright as early twilight now. If you looked at Venus, you'd spot vague swirling patterns in the planet's yellowish-white cloud cover. Venus wouldn't become Earth's satellite. The two planets would likely orbit around their common center of mass, and this orbit would be quite eccentric, like me. But if Venus moved with the same speed as the Moon has now, the two planets would crash into each other in the nearest future. Uh-oh. Okay, let's pull another switcheroo. If Mars was up there in the sky instead of the Moon, you'd surely notice it. Even without a telescope, you'd be able to marvel at its unusual color and dark spots on its surface. And even if you didn't see the red planet, you'd still feel something unusual. Mars is half of Earth's size, but several times larger than the Moon. Replacing a smaller space body with a much bigger one would upset the delicate balance on our planet. If you were unlucky to be at the seaside when Mars took the Moon's place, you'd have to evacuate as soon as possible. Massive waves would rise in the oceans under Martian influence. They would crash against the shoreline like the largest tsunamis. Mars would be reflecting more sunlight than the Moon. Nights would be lighter. Terrestrial landscapes would have an eerie red tint. And you'd be able to admire the tallest mountain in the solar system, Olympus Mons, through a telescope. Mars isn't large enough to change the Earth's orbit dramatically, but with time, the two planets would probably begin to orbit each other, creating a binary planet system. And since Mars would literally be next door, voyages to this planet would become a reality. Okay, now think really big. If Jupiter replaced the Moon, Earth, as an independent planet, wouldn't exist anymore. It would instantly turn into another moon of the largest planet in the solar system. The only positive moment in this transformation? People would have an awesome sky view. Jupiter is dozens of times larger than the Moon. A gigantic, beautifully striped sphere would cover nearly all the horizon. If you had time to enjoy the show, you'd see yellow, brown, red, and white clouds floating in Jupiter's atmosphere. Sadly, the gas giant's gravitational pull would instantly cause severe earthquakes, volcanic eruptions, and tsunamis. Earth's mantle and crust would be drawn toward Jupiter, which would break the planet apart. It'd be stretched and compressed with such force that its surface would bulge back and forth by more than 300 feet. Unfortunately, Earth's speed is only 10% of the speed needed for us to stay in Jupiter's orbit. That's why our sluggish planet would crash into the gas giant in less than a day. Well, that sounds unpleasant, so let's not do that. Now, if Saturn were to replace the Moon, it would be a sight to behold. The planet is more than 35 times larger than our satellite. It means the giant golden globe would cover 18 degrees of the sky, and its rings would stretch even further, from horizon to horizon. Hey, if you like it, then you should have put a ring on it. Earth would be a bit further away from the gas giant than its own moon, Dione. And since Saturn is way more powerful than our planet, Earth would turn into its satellite, not the other way around. Unfortunately, Earth's rotational speed wouldn't be enough to keep up, and we'd most likely crash into the much larger planet within a day or two. But before burning up in Saturn's atmosphere, we'd have to pass through its magnificent rings. They're made up of pieces of comets, asteroids, and shattered moons. It wouldn't be an easy feat to get through this space debris. Plus, our planet would have to avoid Saturn's moons, all 53 of them. But what if the fall didn't happen, and Earth did turn into Saturn's 54th moon? Then the gas giant's gravitational pull would lead to massive tectonic shifts all over our globe. They would be tearing the planet's crust apart until there's nothing left. Not good either. Both Uranus and Neptune are ice giants. These planets are the same size, larger than Earth but smaller than Saturn and Jupiter. They both have icy interiors, deep atmospheres, and similar color, very beautiful bluish-green. If either of these planets replaced the Moon, the consequences would be the same. So let's flip a coin. Okay, it would be Neptune you'd see in the sky one day. Neptune is 14 times larger than the Moon. The planet would look like a bright blue hot air balloon in the sky, not only at night but during the day too. It would appear to be 15 times larger than the Sun. If everything else remained the same, a solar eclipse would seem to continue for ages. Once the Sun vanished behind Neptune's edge, our planet would be plunged into complete darkness for no less than an hour and a half. Neptune is 17 times the mass of Earth, and its gravitational pull is much stronger. That's why our planet would end up as a satellite. Yep, again. It would orbit Neptune slightly further than its own largest moon, Triton. By the way, there would be a great risk of Earth colliding with this space body. But let's assume we were lucky enough not to cross paths with Neptune satellites. Even so, there would be more than enough problems on our hands. Tides on our planet would become 1,000 times more powerful than those caused by the Moon. Neptune's gravitational force wouldn't pull Earth apart, but it would heat our planet up. The seismic activity would increase, setting off earthquakes and volcanic eruptions. And probably louse up the internet too. Okay, picture this. In the not-too-distant future, you're heading out on a space vacation, and you need to decide which items are worth bringing along. But instead of checking the weather forecast, you open a gravity simulator. That's because you need to know how each object will behave on different planets. For instance, should you take this metal shovel with you or not? Well, according to your itinerary, it's going to be a long trip. You're planning to visit every planet in the solar system and even a few moons. But due to the difference in gravity on these space bodies, you're not sure how useful some of the objects you're going to bring along will be. Well, let's start with the basics. Tupperware. I don't know about other space travelers, but us Earthlings carry our Tupperware around everywhere we go. And still, if you were to transport it to, let's say Mercury, it would most likely fly away into the atmosphere. These plastic containers you use to keep your food are too light. And since the gravity on Mercury is 2.5 times weaker as gravity on Earth, well, maybe you'll have to fill your plastic containers up before taking them out of your spaceship to have a picnic. If a Tupperware container weighs about 0.5 pound on Earth, it'll weigh just 1/4 of that on Mercury. Now, if we add some bananas, a handful of baby carrots, and 2 watermelons, then it'll be safe to carry it out of your space vehicle. You'll just have some difficulty making it all fit in a standard-sized container. But wait! Before you do that, you should know that the atmospheric temperature on Mercury can reach up to 800 degrees Fahrenheit. This means that any plastic container will instantly melt as soon as it gets in contact with the air. It'll burn up all the food, too. You can probably try taking a titanium container, that will work, or just stick to astronaut food. Now, shall we say Venus? Okay, Venus. If you were to take the same empty container to Venus, it would behave similarly to how it does on Earth. This is because Venus is also known as our planet's twin. These two have much in common. For example, almost the same size and mass. And when the topic is gravity, the formula goes like this. The bigger the mass and the greater the density, the stronger the gravity. Venus's gravity is approximately 10% weaker than Earth's. So, yes, you may leave your spaceship with your container, empty or full, and enjoy a beautiful and scenic lunch on the surface of Venus. Now, you'll have to figure out a way to eat without taking your spacesuit off, though. The atmosphere of Venus is filled with sulfuric acid, which can irritate your nose and throat and cause difficulties in breathing. Or worse. Much worse. Now, you'll have to forget about taking anything too light outside on Phobos. A little hint for you, it's not a Greek island, not even Greek yogurt, although it's a cool name. It's actually one of Mars's moons. Here, even your spacecraft would need a little extra help to keep close to the ground. If it weighed as much as a school bus, any regular-sized person could pick it up with just one hand. This is because on Phobos, the inhabitants of Earth barely feel the weight of gravity. And be very careful when jumping around because one leap and you may fly straight into outer space.
Passengers on board the Voyager spaceship, please keep your arms and legs inside the vehicle at all times.
Well, you're approaching Jupiter, a gas giant. A never-ending storm is raging in its atmosphere. Plus, there's no solid surface there, which means no landing for you on this planet. If you look out the window, it might seem that you are moving through a giant cloud. But for the purpose of your experiment, it'll work just fine. Try throwing into the air that baseball you brought along in case you get bored of all the space travel. And measure the time it'll take the ball to hit the surface. If on Earth, the ball will fall at a speed of 32,174 feet per second. On Jupiter, the same ball will hit the ground at a speed 2.5 times greater than that. That's because Jupiter is more than 10 times as large as Earth and around 300 times as heavy as our blue planet. Now, if you move your spaceship just a little bit to the side, to one of Jupiter's moons, Europa, the situation will be completely different. Throwing a baseball in the air on Europa will mean never seeing it again. Gravity there is almost non-existent, which means that not only a baseball, but even a grown-up person can fly away any second. Now, on the other hand, if you decided to venture out of the spacecraft to explore Europa's gravitational field, why not try to lift the space vehicle itself? On Europa, a regular Earthling can easily lift up to 1,000 pounds, which is the equivalent of a full-size male moose. Or you can lift a pyramid-like formation of 9 regular people. The choice is yours. When approaching Saturn, be careful. While from afar, Saturn's rings look smooth and solid. From up close, you'll notice that they're made of chunks of ice and rocks floating in space. You won't want to have your spacecraft anywhere near those. There's also no solid surface on Saturn, which makes landing impossible. And the atmosphere is full of ammonia. Keep in mind that it's a pretty inhospitable environment for a human. Now, inside the spaceship, you find a collection of sci-fi books, enough to fill an entire bookshelf. Altogether, they must weigh around 400 pounds. Yep, that many books. And like someone with a superpower, you try to lift over 200 pounds of weight at a time. But guess what? You fail, because Saturn's gravity is too similar to that on Earth. Now, in case you got confused with all this gravity talk, when we're measuring gravity, we're speaking about the power of the force by which a planet or other space body pulls objects toward its center. So, if you need some help in organizing that sci-fi collection in alphabetical order, ask the crew to move the spaceship to a neighboring space body with a weaker gravitational pull, like Pluto. These days, it's not considered a planet anymore, just a dwarf planet and one of the furthest from the Sun's space bodies. You'll need an extra warm spacesuit to wear there. Pluto is freezing cold and has a tiny surface. It's smaller than Earth's moon. But it's a great place to test your strength. If on Earth it's kind of impossible for a regular person to lift an elephant, on Pluto you'll be able to pick up a baby elephant weighing around 265 pounds. Or even a medium-sized elephant that can be as heavy as 2,000 pounds. On your way back to Earth, you make a pit stop on Uranus. The coldest planet in our solar system has an average temperature of around minus 350 degrees Fahrenheit. So, if you attempt to get out of the spacecraft, you'll freeze mid-movement. Although gravity on Uranus is pretty similar to that on Earth, there's one thing that's very different: time. A 2-week getaway on Earth turns into a 3-year-long vacation on Uranus. Now, when you get sick of cold planets, you can travel back to warmer ones. Okay, now, Mars is definitely warmer than Uranus, but its average temperature is still about minus 81 degrees. On Earth, we only have such low temperatures at the South Pole during the winter. When you land on Mars, you'll start to feel light and strong at the same time. Mars's gravity is about 2.5 times weaker than that on Earth. So, in other words, you'll probably manage to lift your own body weight without any difficulty. So, all those handstands you've been dreaming of doing, you've found a place to fulfill your dream. So, you're standing in the lab, and you hear a strong humming sound behind you. Keys, a cell phone, and other metal objects begin to shake and move. Suddenly, they take off and rush past you at a tremendous speed. No, it's not a monstrous black hole that's appeared behind you, devouring everything around it. It's an MRI machine that's just turned on, and you can use it to look inside almost anything. The MRI, magnetic resonance imaging machine, can be the size of a big SUV, but it only consists of 4 parts: gradient, radio waves, a computer, and the key component, a huge magnet. And we need something we're going to look at. Let's take this cute turtle. Most living organisms are made of water. Water is 1 oxygen plus 2 hydrogen atoms. H2O? Yeah. The tiny particles of hydrogen atoms act like microscopic magnets. So we take them as the arrow of a compass. A regular compass detects the Earth's magnetic field, and its arrow always points north. Now, let's put a magnet next to the compass. Its magnetic field is stronger than the Earth's, and we control the compass arrow. MRI machines use large, round magnets that have a magnetic field 60,000 times stronger than Earth's. And when this giant magnet rotates, it makes the hydrogen atoms in the body rotate too. But not all the hydrogen atoms are spinning here. The ones that are standing still are called low-energy water molecules. We make them turn with radio waves. The MRI machine emits radio waves at the same frequency as a magnetic field. The low-energy water molecules absorb this energy and start spinning just like normal molecules. Then we stop the radio waves. The low-energy water molecules stop spinning and give that energy back, and the MRI machine picks up those signals. This information is then transmitted to the computer, which does the calculations and creates an image of what's inside the turtle's body. We can see different parts of the body as pictures drawn in different colors. That's because they have different amounts of low-energy water molecules. Areas containing a lot of liquid are almost white. The turtle shell appears really dark, almost black on the scan, because it's mostly made of bone, containing little water. The less water a body part contains, the darker it appears on the screen. The MRI operator can switch the current to the magnet to take a high-quality picture. At this point, you may hear a strange clicking sound. The great thing about the MRI machine is that we can look inside the body at any depth. Imagine there's an invisible wall moving inside the scanner tube. We can see what's inside the body at every inch of its movement. The gradient in the MRI machine is responsible for that. It divides the large beams of the magnetic field into smaller ones, and it helps to look inside the turtle at any point from its head to its tail. Let's put an egg in the MRI machine and look at the computer screen. First, we see a small circle. It's the top of the egg, 1 inch forward. The circle got a little bigger. Another inch and another circle of a different color appears inside the big one. It's the yolk. It has a different amount of low-energy water molecules and has a brand new color in the image. Step by step, we can examine the whole egg. Still, the MRI machine can't look inside just anything. We have a box with a secret and we want to find out what's inside of it. We put it in the MRI machine and see nothing. The box is made of plastic, and there are no low-energy water molecules in it. There are almost no water molecules at all. That's why it's invisible for the MRI machine. We can make the MRI picture clearer. Let's give our turtle some contrast fluid. It contains iodine salts, which also have some magnetic properties. The fluid spreads through the vessels of the body, and soft tissues absorb it. The contrast fluid amplifies the magnetic signal coming from the body to the MRI machine, so we have a more detailed picture on the computer. But if the turtle wore braces or was wearing makeup, it would distort the scan results. The braces, made of magnetic metal, can get hot in the mouth during the scan. If the machine is powerful enough, those metal parts may even start to vibrate. No worries, stories that the MRI machine can attract small metal particles at tremendous speeds are myths. Still, the vibration on the teeth causes discomfort, and our turtle wants to stop scanning. For this purpose, it has a special remote control with the help of which it can always call for help. However, the turtle has no thumbs and can't press the button, and eventually, hey, let's save this guy and press the button for him. Whew, almost had some turtle fireworks there. But hey, we did have you believing turtles can't have braces and wear makeup. Anyway, if the power of the MRI machine is low and it doesn't react with the metal on the teeth or makeup, it will ruin the picture. You see empty areas in these spots on the screen. The magnetic field of the metal prevented the machine from picking up the signal from your hydrogen molecules. For this reason, you'll have to go through an extensive checklist before the examination. The doctor will ask you about any surgeries you had to see if you have any metal implants in your body. You'll also have to leave all the metal objects like earrings, your belt, your watch. Don't forget to pull the phone and keys out of your pockets. It's not only about your safety, it's also about the examination accuracy. Another problem a turtle might face is claustrophobia. We'll ignore for the moment the fact he lives in a shell. The part of the MRI machine in which you get scanned is a tube. We don't want the turtle to feel uncomfortable. Plus, any movement during the scan might ruin all the results. For such cases, we use low-power MRI machines. They don't look like a tube. They have one semicircle at the top and another at the bottom. And there's open space on the sides of the table. Okay, now Mr. Turtle feels much better. The only drawback is that the computer's picture is much less detailed than on larger machines. The MRI machine is costly. The price tag depends on the power of the magnetic field measured in Tesla, the measurement scale, not the electric car. It starts at $150,000 for a used MRI machine and can be as high as $1.2 million for a new 0.3 Tesla machine. That's like 5 fancy Ferrari cars. Top-of-the-line 3 Tesla machines can cost up to $3 million. Add to that a special room that will protect others from the strong magnetic field and accommodate the machine itself. Total price is now $5 million. But it's a price to pay because, unlike X-rays, MRIs are not dangerous. An X-ray machine consists of a power cell, an emitter, a stand to operate it, and an image fixture. An X-ray works basically like a camera. Let's take a picture of our turtle. The emitter tube emits X-rays. Unlike rays of light, these rays can pass through the body and then reach the image fixing device, and the computer shows the results. Different body parts absorb these rays differently. Air doesn't absorb X-rays at all, so it's dark in the picture. Soft tissues absorb only some of the energy, and they are lighter. Bones absorb most of the X-rays, so these are the lightest areas of the photo. Our turtle shell is bone, so we see a big oval in the picture, which prevents us from seeing anything underneath it. And we can also see the turtle's cute little limbs. But the X-ray machine can't capture what's inside the body. It just takes a picture of the outside. So they usually take another snapshot of the desired object, only this time from the other side. Unlike an MRI, X-rays can be dangerous, so the parts of the body that you don't want to examine need to be protected from radiation. The room with the X-ray machine must have a special shield so radiation doesn't go anywhere else. On the bright side, X-ray machines cost 10 to 20 times less than MRI machines. Also, X-ray machines can reveal what's inside the secret box our MRI failed to examine. Airport employees use X-ray machines when they scan our luggage. Steel objects like nail clippers absorb X-rays perfectly, and they literally glow on the screen. TRES-2b, or not to be, is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here it's pitch dark and scorching hot. TRES-2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. Lovely. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather the first because it's closest to the star, is different in a most horrible way. 55 Cancri e is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star on one side. And between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. That's a getaway spot. HD 189377b, oh, I'm not going to say that again, is the only exoplanet in the orbit of its star. And at first glance, it looks quite pretty, blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. Well, for comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. Better duck. The next system, whose name I won't even try to pronounce, this one, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular. It's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely. Kepler-70, hey, I can say that one, is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler-70b, and it still exists, but the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our Sun. It was lucky to survive spending time inside the star, but it's evaporating now and will probably be no more in the near future. WASP-12b is one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planets consisting mostly of gas, result in the star slowly devouring its protege. So pal, what's eating you? My mother. WASP-12b has already taken the form of an egg, stretched toward its merciless sun, and it's unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. Hey, you asked. If you ever wondered what it's like to walk on ice and hot coals at the same time, Gliese 436b is a planet that would give you a vivid example. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven, and yet it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. No list of frightening worlds could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours, and those clouds I mentioned are not made of water but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave, or crazy, enough to try to pass through these clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. Here we have a very long name for a very, very cold planet. Although the host star is not too far away, it's a small and rather cool red dwarf, whose light and heat barely even reach the planet. The temperatures out there fall as low as minus 370 degrees, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice that never thaws. I thought I thaw that somewhere. Still, if it has a rocky core, it might generate some heat, so there's a chance that deep below the frozen surface, some unknown alien things might lurk. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1,800 degrees, perpetually blown over with winds reaching 600 miles per hour. And that's winter. Well, actually, I don't know that. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when those cool down, they fall on the surface in the infernal rain of molten iron. That'll test your mettle. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot, where anything that could burn will. It's also responsible for a very short orbit of the planet around the star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. Vacation? Nah, let's keep looking. Karat XO 3b is neither as hot nor as cold as some of the others on this list, but it's terrifying in its own more insidious way. It's a gas giant similar in size to Jupiter, yet 20 times denser. This makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. Karat 7b is another oven-like world. Its day-to-day temperature is over 4,000 degrees. Combined with the rocky surface, it presents an infernal landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Karat 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core.
Hello, Brightsiders! Do you want to ride the world's fastest train ever? So you're at the station waiting for the train, and suddenly a strong gust of wind blows up and people's hats fly up in the air. This gust was caused by the fastest train in the world, which just passed your station at 375 miles per hour without making a sound. What is this miracle? It is the SC maglev train developed by Japan Railways Company, and it has set a new world record for speed and will connect Japan's largest cities, Tokyo, Nagoya, and Osaka. The entire route will take 67 minutes. So this train could make the trip from New York to Washington, D.C. in just 1 hour. That's faster than getting there by a plane. And at the same time, the train wouldn't create noise or pollute the atmosphere. After all, it doesn't even have an engine. And it doesn't make the wheels clatter against the rails because the train levitates in the air and doesn't touch the ground. And there aren't even any rails. Do you want to know how it works? Let me tell you. Let's take a look under the skin of the train. All the train uses to move is magnets, or rather, superconducting magnets. These ovals are our supermagnets. So what's so special about them? If you run an electric current through them, they create a strong magnetic field around themselves. You can see it on these lines. And the more robust the current, the bigger and more powerful the magnetic field is. But the electric current gradually heats the magnet and its efficiency goes down. The magnetic field gets weaker too. Because of the high temperature, the magnet creates more resistance to the current. A regular phone charger works pretty much the same way. The wire can get hot when you charge your phone because it creates a slight resistance to the electric current, like in our electromagnets on the train. The obvious solution is to cool the magnet down to turn it into a superconductor. We can do this if we reach a temperature of minus 440 degrees Fahrenheit. It's almost like the temperature of outer space. At that temperature, the magnet material stops resisting electric current altogether. That's why it's called a superconductor. The main advantage of this is that we don't need to supply electric current to the magnet all the time. We only need to charge the magnet once. Then the current will circle inside it indefinitely and the magnetic field will be solid. So how do we reach this super low temperature? To cool the electromagnet, we need a liquid helium tank. This frigid substance circulates in the case around the magnet and cools it. As it does, the helium evaporates and goes to a kind of a refrigerator. There, it's cooled again and compressed to its original state. And the liquid helium is sent back into the tank at the end of the cycle. But even that's not enough to keep the magnet in a superconductor state. So the engineers added another heat shield. It's a kind of a box with liquid nitrogen circulating in it. It goes through the same cycle as the liquid helium. Such blocks of 4 superconducting magnets and cooling units are installed along the entire length of the train on either side. And these magnets are only half of the force that makes the train move. The other half is hidden in the guideways. So what's inside there? Similar O-shaped electromagnets are mounted on the sides of the guideway. The polarity alternates between north-south and north-south, north-south, and it just keeps going like that. Just like the polarity of the magnets inside the train. Now, let's put our trains on a guideway. You can see that the magnets inside the train and the guideway are on the same level. So, how do we make a train move without it having an engine? We know that the opposite poles of magnets, north and south, will attract, and the matching charges will push back like north and north. These arrows show the forces of attraction and repulsion of the magnets, and all the forces here are directed diagonally. The resulting force here is directed forward, and the train is starting to move forward a little bit. Now, the train has to reverse the polarity of its magnets. This is done by changing the direction of the electric current inside the magnets. Again, there are those forces of attraction and repulsion between the train and the guideway, and the train keeps going. The driver can adjust the train's speed by changing the polarity of the magnets. The more often north changes to south, the faster the train will go. But why doesn't the train fall off to the ground? It is the most exciting thing about the train: levitation. Many people think that the train doesn't touch the ground because the bottom of the train is a giant magnet. At the same time, the guideway is a huge magnet of the same polarity. The magnets repel and the train levitates. That's not true. The magnets on the sides of the guideway do all the work. They're the same O-shaped magnets, only twisted so that they look like a number 8. Imagine a pair of magnets within either side of the train is one giant magnet. The north is on the left and the south is on the right. It hangs precisely in the middle of the 8-shaped magnet when the train rides. But gravity forces the train down. Then the train's magnetic field charges this 8-shaped coil. Now an electric current is moving in it too. As a result, the top loop of the magnet is charged south and the bottom loop north. The magnets interact and the resulting force is directed upward and the train rises. The same thing happens when the train goes down. The 8-shaped magnets are charged so that the top loop is north and the bottom south. The resulting force is downward and the train goes down. It happens on its own thanks to the laws of physics, without the driver even needing to do anything. And the train keeps going, floating above the guideway at the height of about 4 inches. That's like the height of a toothpaste tube. So the train can only levitate when it moves? Exactly. That doesn't mean that it just falls to the ground when it arrives at the station. Maglev has regular wheels for this as well. The train stands on the wheels at the station and then picks up the speed on them. The wheels retract like airplane landing gear when it reaches about 95 miles per hour. And the driver only lowers them when they need to stop at the station again. But if it doesn't have wheels, it can't turn, right? Well, yes, but it turns and maneuvers using the guideway. It is done by these identical 8-shaped coils we've seen before. They're connected to each other under the guideway's surface. When the train shifts to the right, its magnets charge the coils. But because the train's magnets are more toward the right coil, it's charged more. And the magnetic field is much stronger there. It creates a force that pushes the train back to the center of the guideway. The same thing happens if the train moves to the left. The coil charges and the magnetic field pushes the train to the center. Ding ding! The bell sounds and the maglev departs from the station in Tokyo. It accelerates to the speed where the magnetic field will allow it to levitate, and the driver removes the wheels and increases the speed. The train reverses the polarity of the magnets in a fraction of a second and the train accelerates. In an hour, the train arrives at its destination. The driver slows the machine down and the magnetic field becomes weaker. It's time to let the wheels out. The train lands and begins to slow down. Such an advanced technology must have a lot of problems, right? Well, yes. The first is size. The maglev is much smaller and can carry fewer passengers. Also, the rails can change direction for a train in a couple of seconds, but to change a guideway direction for a maglev would require more expensive and much slower technology. So, on the same stretch of guideway, high-speed trains on rails can run every 3 minutes compared to 10 for a maglev train. Another problem is aerodynamics. The faster the train goes, the harder it is for it to get through the air. At 190 miles per hour, the maglev and the other superfast trains use about the same amount of energy. But at the speeds above 310 miles per hour, the maglev will consume 4 times as much electricity. And given the small number of passengers on the train, tickets to it will be so much more expensive than conventional trains. In addition, the maglev can't run on traditional rails, and the engineers will need to build an utterly new guideway route. And they'll need to drill a lot of tunnels, which will make the project even more expensive. So why would Japan need such an expensive and impractical solution? For several reasons. The first is seismic activity. Japan is the site of many earthquakes, and traditional rails often get damaged. An earthquake can destroy the entire infrastructure in just a couple of minutes. Maglev's guideways will be laid further off the coast in the so-called green zone, where earthquakes won't threaten the train or the guideways. And the main reason, this high-speed train will connect 3 heavily populated cities. The route from one to another will take 1 hour at most. It will give a massive chance for overall economic growth and could bring in a lot of money in the future. Also, Japan is considering selling this train to other countries. So, would you want this train in your state? And if so, where would your first trip be to? Leave the answers in the comments.
This is our home planet Earth and its satellite, the Moon. Zooming out, and here's our solar system. A bit more, the Milky Way galaxy. And we're a small dot among an infinite number of stars. Now, even farther out, a cluster of galaxies. Dots and swirls in the endless space. Further, there's Laniakea supercluster. That little dot here is our galaxy. Moving on, Hydra Centaurus supercluster. Huge clusters comprising thousands of galaxies are no more than a speck from here. Next, Pavo Indus supercluster. This is an area 200 million light-years wide. We can zoom out until we see the entire observable universe. Each little dot in here actually contains thousands of galaxies and quadrillion stars. Scientists speculate that our universe may look like a bubble, and that bubble might collide with another universe. Yes, other universes could exist. Actually, even a whole infinite number of those. All of them could have appeared after the Big Bang. The collision between them isn't impossible either. At least, it might have happened before. And the proof is here, in the direction of the constellation Uranus. This place is called Uranus Supervoid. It's about 1 billion light-years wide. By comparison, the width of our entire galaxy is only about 100,000 light-years. There's absolutely nothing in this place, and it may be a trace from an old collision between our universe and another. Scientists think they were passing by each other. When the distance between them was minimal, the gravitational forces of the bubbles began to pull toward each other, just like two drops of water trying to connect when they're close. But the speed of the universes was too high for them to continue interacting, so the other universe just tore out a piece of our bubble. There might have been about 10,000 galaxies in that void, and all of them were either destroyed or taken over by the other universe. Let's travel to the edge of our universe to see how this collision might have taken place. We're 10 billion light-years away from our home. Here, in another galaxy, we see amazing nebulae of different colors and shapes. And if you look in the other direction, there's a huge wall moving at us. All these bright sparks on it are enormous galaxies about to collide with us. But in fact, it's a humongous mirror that only reflects our universe. Here, space-time is distorted and begins to be pulled into another universe at a tremendous speed. The usual law of physics may simply stop working at this point. Gravity may disappear, and with it, all the stars would explode and people on the surface of planets would hang in weightlessness. But if the universes didn't go at a tangent but crashed directly into each other, things would be much scarier. The enormous amount of collision energy would probably cause an incredible explosion. Its force would simply destroy everything in our bubbles. Still, the two bubbles might begin to merge too. At first, all galaxies at the edge of the universes would be torn apart, but then the merger would begin. The galaxies would start moving chaotically. They would fly past each other, break apart, collide, and explode. The collision of two galaxies is an accident of enormous proportions, and it might happen to our home quite soon, in space terms. The Andromeda Galaxy is heading our way. It's a spiral galaxy about twice the size of ours, and there are about 1 trillion stars there, which is twice more than in our Milky Way. At the very center of this bright galaxy lurks a dark beast, a black hole. Its weight is 2 and 8 zeros of the Sun's mass. Red giants hundreds of times larger than our Sun. Pulsars emitting enormous amount of energy like spotlights. Rogue stars, and many large and small black holes. This soup of dangerous objects is moving toward us at 68 miles per second. A trip to New York to Los Angeles at that speed would only take half a minute. The disk of Andromeda can already be seen with the unaided eye on moonless nights. As time goes on, it'll get even bigger. As Andromeda gets closer to us, its gravitational force will begin to stretch the arms of our spiral galaxy. It'll begin to unwind. The stars and planets will lose their orbits. One possible scenario is that an unknown asteroid, or even a dwarf planet from the Andromeda Galaxy, will crash into the Earth at an incredible speed. Our planet will explode just like a balloon from this impact. Oh, goody. Another option involves stellar collisions. Our Sun would face another star. The bigger star will slowly begin to consume the smaller one. First, it will steal the light upper layers from it, and then it will eat it just like spaghetti. Or even like rigatoni. When a large star reaches its critical weight, it will burst. This explosion will destroy everything around it, including our solar system. Perhaps the shockwave will even reach other neighboring stars. Yet another scenario is that our solar system will be thrown into dark space. Imagine a tennis ball tied to a rope. You take the rope and spin the ball over your head like a sling. Then you let go of the rope and send the ball flying. This is what will happen to the Sun and all the planets around it. We'll find ourselves in dark and cold space. But life on Earth will not be affected. We'll still have our bright star to keep us warm. The only disadvantage is that all the stars in our night sky will disappear. And the most likely possibility is that the merger of two giant galaxies will have no effect on us at all. The thing is, the distance between stars and planets in space is enormous, so they can all just mix together and form one giant cloud. It would be like shoveling fine sand through a big sieve. The objects won't interact with each other. But the most interesting thing will happen to the black holes in the centers of our galaxies. Right now, there's a dense cluster of stardust and stars around them. As Andromeda and the Milky Way come closer together, they will begin to dance with each other. Gee, will it be the twist or the foxtrot? And when the black holes get close together, they'll begin to swallow all matter around one another. Billions of tons of colored stardust, asteroids, and star particles will fly toward the very center of either black hole. It might seem like this process happens very slowly, but it's an illusion. Super heavy objects like black holes warp the space-time grid, so time is much slower near black holes. And all objects that seemingly stay on the event horizon for weeks or even months are actually long gone. When the black holes finally come together, they merge into one supergiant black hole, but its mass is slightly less than the combined mass of the two dark monsters. Some of their weight is transformed into collision energy. This energy is released so strongly that its waves can be felt in other galaxies. Now, a huge black hole gathers all this dense and hot core of the two galaxies around itself. At some point, the black hole feels full and throws out powerful jets of energy into space. This is called an active galactic nucleus. It's one of the brightest phenomena in the universe and the most powerful source of electromagnetic radiation ever known. These jets may be more than 5,000 light-years long. By comparison, the distance from Earth to the nearest star, Proxima Centauri, is only 4.2 light-years. And the explosion that accompanies the jets has the power of 100 supernova explosions. Wow, blows my mind. The blast wave from this event could even reach the edges of a new galaxy, and this outburst would be visible from millions of light-years away. Now, there are dense clouds of multicolored dust at the center of merged galaxies. The weight of these clouds is so great that they begin to shrink and take on a round shape. Gradually, they become so heavy that they compress the core and nuclear reactions start inside them. The temperature begins to rise and soon, boom, there's a supernova. It's a veritable fireworks show at the center of the galaxies. Stars erupt from the fog and form new hot worlds. At this point, the arms of the two galaxies that were previously pulled out slowly return to their former shape. The super-heavy center of our galaxy has such a gravitational force that it affects stars and nebula hundreds of thousands of light-years away. The galaxy's arms twist again, and we see the new and finished galaxy, the Milkomeda, or Milkdromeda. Hey, how about the Andro-Milky Meter way? Blah blah blah. Well, that's hard to say. You're driving on an empty highway and humming to your favorite track on the radio. Suddenly, a deer runs out onto the road. You look at each other in shock, and a moment later, you hit the brakes as hard as you can. You hear tires screeching. The car starts to slide on the asphalt, unable to stop. Smoke is coming out from under the wheels. In a second, the car starts to skid and swerve, and you're getting ever closer to that deer. A few more feet, and you miraculously stop right before you and Bambi have lunch. This situation might have been different if your car had had ABS, anti-lock braking system. Here's your car going down the road. Let's take a closer look at the wheels. You step on the brake pedal. At that moment, the brake pads press against the spinning brake disc, and if you press the pedal too hard, the car's wheels lock. But the car loses traction, and now it begins to slide on its wheels. In this case, the braking distance will be too long to avoid an accident. Now, let's take a look at the tire itself. When braking begins, the tire deforms as if it were pulling back, and then the brake performance is even worse. Experienced drivers know that even in the most urgent situation, you shouldn't hit the brake pedal with all your strength. You need to apply a little less pressure than it takes to lock up the wheels, or you can brake in several strokes. When you feel that the wheels are locked up, you have to release the brake pedal and then start braking again. That's exactly what the ABS does. There's a sensor on each of the brake discs linked to the central computer. Even when the brake pedal is pressed to the limit, the sensors send an alarm to the computer, and it gives a command to reduce the pressure on the braking system. The wheel starts spinning again. Then the pressure increases and the braking resumes. The ABS has to release the wheel lock right before the tire starts to deform. This braking will take as little distance as possible so you can avoid a collision. ABS doesn't only work in emergency situations. Let's say you're driving down a road which is drying out from an early rain shower. Your right wheels are on wet asphalt while your left ones are on the dry part. Wet asphalt is much more slippery. Even if you brake very calmly, your tires still feel different friction against the asphalt. In that case, your car might just swerve. ABS feels this, and it can apply different brake pressure to each wheel. Even when you drive on a completely wet road, struggling with puddles, your brakes understand when a wheel has hit a puddle and it gets too slippery. The computer instantly sends out orders to each wheel, and your car continues to drive smoothly. It also allows you to maneuver while braking. When the wheels are locked, you can turn the steering wheel any way you want, but the car will continue to slide and won't change direction. ABS allows the wheels to keep turning during braking, so when you give direction with the steering wheel, the car will listen to you. The brake assist system teams up with ABS. Let's say you're driving on a flat freeway at the speed limit. Your path is clear and you feel relaxed. Suddenly, there's an obstacle on the road, and you have literally a fraction of a second to hit the brakes. Studies show that in emergency situations, drivers don't press the brake pedal all the way down. The braking distance will be longer than necessary, and an accident might occur. Brake assist system senses that you've pressed the pedal sharply. That means it's an emergency. It pushes the pedal all the way down to brake as efficiently as possible. If you brake hard in a calm situation, you can see how this system works. The brake pedal will start to fall down itself or move away from your foot a little bit. It's actually the car bringing the brake all the way down for you. So remember, when you drive, your movements should be calm and smooth. If you like to drive in all weather conditions, your safety will be kept by the traction control system. You're driving on a wet and slippery highway and there's a sharp turn ahead. You turn the steering wheel and go into it. The turned wheels hit a puddle and the grip gets worse. The wheels begin to spin much faster than when touching the road. If you do nothing and keep driving, as soon as the wheels touch the asphalt again, you'll lose control. You'll skid and go off the road. The traction control system uses the same sensors as the ABS, plus a few other clever details. They count the number of rotations on each wheel. When one wheel starts spinning faster than the others, the system feels the slipping. The main computer takes the signal and finds a solution. One option is to reduce the engine speed. The system can cut off the fuel supply to some of the cylinders of the engine, or stop the ignition process in the cylinder itself. Then the engine speed drops and the wheels slow down. Another way is to command some of the brakes to slow the rotation of the wheels. The slipping stops and you can maintain control of the car even in the most difficult situation and in any weather. The anti-lock braking system also helps the adaptive cruise control work. Cruise control is a smart system that helps you keep a certain speed without your own effort. You simply set the desired speed and take your foot off the gas pedal. The system adds or reduces the throttle itself to stick to that speed. It's basically an autopilot. All you have to do is steer and keep your eyes on the road. But if you're approaching a hazard, the car won't slow down by itself, so no snoozing. Adaptive cruise control is there for your safety. With it, the car is equipped with several sensors, cameras, and a radar. You set the speed and move with the traffic on the highway. The radar emits waves in front of the car. Any metal object bounces those waves back to radar sensors. This way, the radar and the computer understand the distance to those objects. If that distance is getting shorter, the computer slows the car down. If there are no obstacles ahead, it'll keep the set speed. But what if a car cuts into your lane? The radar can see objects more than 300 feet away, so it notices the new obstacle immediately. If it's far enough, you'll just get a warning that you should start braking. If the distance continues to decrease, the system itself starts to slow you down. But if the obstacle in front of you is too sudden, the computer will order the car to begin emergency braking. The first two steps can even be skipped if the situation isn't safe. Starting uphill is another common cause of collisions on the road. Now, pretend you're driving on the streets of San Francisco, stuck in traffic at a red light on a steep uphill. Yeah, been there, done that. There's another car behind you. You see the green light and take your foot off the brake pedal to step on the gas. But the second you move your foot, the car starts rolling backwards and bam, you bump into the car behind. To save you this trouble, there's the Hill Start Assist System, or HSA. The system leaves the wheels locked while you switch your foot from the brake to the gas pedal. Then HSA removes the brake lock and you have time to step on the gas pedal, preventing gravity from pulling you downhill. But if you're standing at a red light on a regular flat road and let go of the brake pedal to hit the gas, the system will still keep the brakes active. This could not only hold you back on the road, but cause a rear-end crash. We don't need that, so the designers installed a few details to help the main computer know if the car is on a slope or not, making HSA cleverer. And now, depending on the incline, HSA behaves differently. If the slope is slight, as soon as you take your foot off the brake pedal, the system begins to slowly take pressure off the brakes. It releases them completely when you put your foot on the gas pedal. If the slope is very steep, when you take your foot off the brake pedal and start gently pushing on the gas, HSA will still keep the wheels locked. It will only release them when you hit the gas hard enough for the car to start off uphill. The same thing happens when you need to move in reverse up a hill. You need even more time to assess the situation on the road and look in all your mirrors. So the HSA will keep the brakes holding you there until you get enough throttle to start moving. So here's your school locker with a combination lock. Let's take it apart to see how it works. The whole mechanism is hidden in a metal case. The part that opens and closes the lock is this curved metal stick called a shackle. One end is longer than the other, and it cannot be taken out of the case. The shackle collar is attached to its tip and follows the shackle as it moves. When the lock is opened, the collar rests on the upper stopper and doesn't allow the shackle to be pulled out of the case. The heart of the lock is the lever. This piece of metal is crescent-shaped at the bottom and attaches to the case on a pin that allows it to rotate. The lever has a slot that hides the latch. It's attached to the lever on a spring that pushes it into the slot on the shackle like a puzzle. There's also a flexible metal plate that attaches to the lever parallel to the latch. So here's the closed position of the latch inside the shackle. When we tried to take the shackle out to open the lock, the lever starts to rotate. Latch spring compresses and releases the shackle. Now the shackle can be removed and the lock is opened. At the same time, the flexible metal plate resists against the case and forces the lever back into its original position. When you close the lock, you push the shackle down. It presses on the latch and causes its spring to compress. Then the spring pushes the latch back into the slot and the lock is closed again. But we can see that we can open the lock just by pulling the shackle out. So we need a mechanism that will prevent the lever from turning freely and keep the lock closed. This is where our combination mechanism comes in. It's attached to the back plate of the lock. There's a pin with a spring and 3 metal discs with washers between them. Each disc has an oval notch and so-called teeth. The second and third discs can rotate independently, but the first one attaches directly to the combination wheel and will only rotate if you turn the wheel from the outside. Let's put our combination mechanism into the case. The lever is crescent-shaped at the bottom, so just the round discs of the mechanism can rotate there. The lever can only rotate when the oval notches on all 3 discs line up in the same position. Now, one end of the crescent can drop into these notches, so you pull the shackle outward, it makes the lever rotate. The notches on the code discs let it do that, and you can pull the shackle out and open the lock. But when at least one of the discs of the mechanism isn't lined up with the others, the lever can't rotate because the left end of the crescent at the bottom rests against the disc. Now you can't lift the shackle, and the lock remains closed. So you can operate the first disc of the code mechanism directly, but the rest will stay in place. We have teeth on each disc for this purpose. Let's take a closer look at the mechanism. You start rotating the first disc. As it makes a full circle, the disc hooks a tooth on the second disc and they start turning together. Then the second disc makes a full circle and engages the tooth of the third disc. And now all 3 discs rotate together. Now let's see how to line them up to open the lock. First, we need to make 3 full turns to get all the discs moving. The first number of our combination is 20. When we stop the combination wheel at this mark, we set the third disc in the proper position. Now we need to start turning the wheel in the opposite direction. Again, we do a full circle so that the teeth of the first disc can engage the second one. When they move together, we spin them to the second number of the combination, 10. Done. We rotate the disc in the opposite direction again and immediately set the last number. We've got number 35 here. Now all the mechanism's discs are set in the correct position. Time to pull the shackle up. The lever begins to rotate and its lower tip drops into the notches on the discs. Once the shackle is removed, the flexible plate forces the lever back into the start position. To close the lock, you have to push the shackle back into the case. The shackle presses on the latch, compressing its spring. When the latch comes to the shackle slot, it causes a slight jolt inside the lock. It's enough to move the combination discs a little to the sides. Now they're not lined up in a row, and the lock can't be opened without re-entering the code. For even more safety, always turn the combination wheel several times so that the discs are in completely random positions. But even if you forgot the combination to open your lock, you'll still be able to open it. Take the lock in one hand and put a little pressure on the shackle, pushing it up a little as if trying to open the lock. With your other hand, twist the combination wheel twice. Then start turning the dial slowly. When you hear a click, stop. It means the disc number 3 is in position, and the lever is trying to get into the notches on the discs. Write this number down. If the lock clicks at every digit, you are pushing the shackle too hard. If there's no click in a full circle, you're not pushing hard enough. Once you know the first number, start turning the wheel in the opposite direction. The rules are the same: light pressure and slow rotation. Write down the second number. Now, slowly turn the dial wheel in the opposite direction. Once disc number 1 is in position, the lock will open. And so ends the lesson for Safe Cracking 101. Sometimes manufacturers make more than 3 discs. For example, there can be 6 of them. Now, you have to line up 6 discs to turn the lock. It will increase the size of the lock, but will make it more secure. The lock codes on safes work differently. Here it is. It consists of a combination dial wheel, a spring, 3 discs with notches, a small wheel, and a fence. The handle of the safe is connected to the lever, but you can't lower the handle completely because the fence blocks the rotation of the lever. So we have to enter the combination to remove the fence and lower the safe handle. When you spin the dial wheel, you are not spinning the first wheel, but the last one on the other side of the lock. This is because the teeth of the wheel start turning the first disc, the teeth on the first disc spin the second one, and so on. The first digit in the combination is responsible for the disc set closest to the wheel. The notch on the disc should be directly under the fence. We spin the combination wheel in the opposite direction to set the second disc in the correct position. We reverse the direction of rotation again and set the third disc in the right position. The fence can now drop into the notches. It no longer locks the lever, and you are free to press the handle of the safe and open the door. The great thing about this locking device is that the fence will not come down on the discs until they are all lined up in the correct position. So when you try to open the safe without knowing the code, the lock will not make clicks that you can use to find the right numbers of the combination. You can try to figure out the code though. To do this, you select the first digit 1, the second digit 1, and the last one on the dial wheel. You pull the handle and nothing. Now the combination is 112, then 113, and so on. The chance of you getting the right digit for the first disc is 1 to 99 because there's only 99 digits on the dial wheel. The odds that you'll guess the correct digits for the first 2 discs are 1 in 9,702, and the probability that you can pick the correct code for all 3 discs is 1 in 941,094. To open such a lock without knowing the combination, you'll need a drill and a small camera. First, you have to know exactly where the door's combination mechanism is and drill a hole right in front of the notches on the discs. Now you stick your little camera with the flashlight in there. We can see the discs spinning on the screen. We have to turn the dial until you see that the first disc is in the right position, then the second and the third. It won't be easy to drill such a hole, however. Usually, safe doors are made of several metal layers with a layer of solid concrete between them. And if you do this at a bank and get caught, well then you'll get an education as to how the legal system works up close and personal. Step 1. Get a good lawyer. This is LUCA. Its name stands for Last Universal Common Ancestor. It's a bacterium, and nobody knows what it actually looked like, but genetics helped us find it at least. All living things have their own genetic code. Picture it as a book. It's written using an alphabet of just 4 letters, A, T, C, and G. They make up 64 words, each containing 3 letters. And the sequence of these words is the genetic code. You, me, a cactus on your windowsill, a spider on the wall, that dog outside. Yeah, we're all relatives because our genes are written in the same language. For example, the text in the code books of humans and chimpanzees differs by only 1%. Luca lived 4.5 billion years before you watch this video. This bacterium is a seed, and the tree of life on Earth has grown out of it. It wasn't the first, but everyone started from it. The planet's been changing. At first, there were only oceans. Then, dry land appeared. Mountains rose and fell. Droughts were followed by ice ages. Life on it changed along with the planet. In the beginning, single-celled organisms appeared. But billions of years later, life got much more complicated. Tell me about it. 600 million years ago, the face of the Earth resembled some sci-fi blockbuster. Life was only in the ocean and in the form of mysterious animals ranging in size from a matchbox to a modern shark. They looked like tree leaves, living blankets, ribbons of cloth, or bags filled with jelly. The Cambrian explosion took place 540 million years ago. Species grew much more varied, many of them now having heads and tails, which helped them change direction in the water. The ancestors of modern fish, amphibians, crayfish, insects, and spiders appeared. These creatures still resembled monsters from horror films. All life was concentrated in water, but not for long. 500 million years ago, terrestrial plants appeared. Amphibians followed them onto land. Scientists believe the first was Scorpio venator, the ancestor of all modern scorpions. Strange as it sounds, seeds only appeared 350 million years ago. Before that, all plants were seedless. As for flowers, they'd only start bringing joy to the eye 220 million years later. It's time for the people's favorites. Dinosaurs entered the age of evolution 240 million years ago. Meat and plant eating, terrestrial and flying, huge and small, they ruled the planet for millions of years. But in the shade of giant lizards, a strange animal appeared. They were covered with fur and fed their young with milk. They were the first mammals, resembling a modern ferret, rat, and cat all at the same time. Most likely, they were night hunters and lived in trees. 66 million years ago, dinosaurs were gone, but birds remained, their descendants. And 10 million years later, the first primates came. Ancient lemurs were probably their direct ancestors. Leaping forward to 5 million years ago, and human-looking primates already settle in Africa. Wild animals aren't their only problem now. It's gotten colder. Food is scarce, the jungles have diminished, and hiding in the trees is becoming more difficult. Cold was a universal issue back then. Huge glaciers appeared on the planet, absorbing enormous volumes of water. The jungles were turning into dry savannas. Early hominids adapted to survive in the new environment. Hunger drove apes out of the forest into open spaces. There was food here, but dangers were lurking everywhere. Little by little, the primates learned to walk on their hind legs. It helped them notice the enemy faster and to navigate easier through tall grass. With those hands free, they could give signals to relatives or throw stones. 1 million years of living in the savanna made them hominins. Not humans yet, but no longer just animals either. The primates that didn't leave the jungle became the ancestors of chimpanzees. That's why we're so familiar to them. Human evolution isn't a simple timeline. Imagine a show with dozens of seasons running in parallel but overlapping each other. Each season tells a story of a specific hominid. Scientists agreed to call those animals primates. Simply put, humans. You, me, your parents and friends, Homo sapiens. And we're only one of the species of this kind. But the problem is, entire episodes of the show have been lost, and some of the crucial scenes have been cut from the plot. 2.4 million years ago, part of the hominins evolved into the first humans. They were dubbed Homo habilis, or handyman. They were no taller than a modern chimp and made primitive tools out of stone. And thus, the series called Evolution begins. Homo ergaster, or man at work, appeared between 1.8 and 1.5 million years ago. This human version knew how to make tools and was an excellent runner, which made it a good hunter. Any Homo ergaster would teach modern pro athletes a thing or two. This species lived in severe drought conditions and lost almost all of its body hair. Homo erectus, or upright man, most likely appeared in Africa about the same time, but it was the first to go to Asia. Scientists argue whether these species and a dozen more hominids evolved into each other or developed in parallel. Homo sapiens appeared about 300,000 years ago. After 200,000 years, our ancestors left Africa and left to populate the whole world. Climate change became their green light for migration. At the time, Africa turned into an arid desert, and our ancestors went ahead in search of food. In unknown lands, they met other people too. Neanderthals lived in Europe and Western Asia. Because of the glaciers, Europe looked like a freezer, but the Neanderthals felt great. Their big noses warmed up the cold air that went through it, and their muscles and stamina helped them walk in the snow. Solo Man lived in modern Indonesia, and close by, on the island of Flores, amazing and solitary people evolved. They were literally dubbed hobbits. They weighed about 55 pounds and didn't grow taller than 3 feet. Still, unlike their fantasy counterparts who loved to sit near the fireplace and have peaceful fun, the real people were excellent hunters. In 2010, archaeologists excavated the Denisova Cave, Siberia. Here, scientists found a part of a finger belonging to a hominid yet unknown to science. They called it the Denisovian. In the coming millennia, though, all Homo except the sapiens have disappeared. We weren't the strongest or the fastest, but communication helped a lot. Homo sapiens talked, planned their future, and passed ideas to each other. The brains of the first people didn't differ from ours, but their cognitive abilities did. They weren't so good at remembering new things, communicating with each other, discussing phenomena and objects. The brains of Homo sapiens were flexible. Thanks to this, ancient humans gradually adapted to new conditions and changed as a result of experience. Paleontologists claim that Homo erectus used similar stone axes for 1 million years. Their sapient counterparts never stood still and kept improving their tools. They came up with a bow and arrow, needles for sewing clothes, hooks for fishing, a stone knife. They lit their caves not only with fire, but also with a primitive oil lamp. They continue to evolve and are doing so even now. Our development as a species is influenced by the environment, diet, and modern technology. For example, 40,000 years ago, the average person was 6 feet tall. We've been shrinking for millennia, but now people are getting taller again. Researchers believe this is thanks to improved nutrition and health. The tallest people live in the Netherlands today. Their height is similar to that of the first Homo sapiens. Our brains are shrinking too. The people of the past had them 10% bigger. For the early humans, survival was the most prominent issue. Today, people mostly live in safety. So that's probably why our brain continues to get smaller. I know mine is. You were lucky to find that 6 by 6 foot apartment after all. None of your friends own one. They mostly live in capsule modules where it's only possible to sleep without turning and tossing much. The price for what they call a mansion today is obscenely high, and you still fully can't accept it. Tomorrow, you got to sign that contract and make the down payment. Actually, you had the chance to buy it only because you won that chance in the lottery. This is how you live in $29.99, you and the other 100 billion people. Some people, though, invest in numerous new millennium apartment blocks on other planets. The latest real estate trend is to downshift somewhere on Ross 128b, Mars, or even Saturn. You were thinking about it too, but you just love the Earth's atmosphere and nature too much. While you're sipping your morning coffee, a pop-up advertisement hologram instantly fills all the space in your capsule, and it just won't disappear. Dear Earthen, don't miss out on the chance to change your life once and for all. Check out the newest apartment blocks on Ross 128b, Mars, Europa, and Saturn. Invest in your new housing and brand new life. Bus tours available daily. Suddenly, you realize this spam might be your chance. You still have some time before signing that contract. You've got nothing to lose. It's just a one-day tour. After all, 11 light years from Earth to Ross 128b aren't a big deal now. Just a couple of hours on that space bus the agency provides. You'll go there and see that there's no place like Earth, just to make sure you've made the right choice. You rush to the space bus station, and you're just in time. 3, 2, 1, go. The bus pulls out, and 2 hours later, you're already there on Ross 128b. Wow. It looks like a bit of old-fashioned Earth you've seen in scientific presentations at university. The surface is rocky with some green spots. These must be the forests and meadows scientists are trying to introduce. It does have an atmosphere, although artificial. The real estate agent says it's actually good. No unpredicted weather anymore. Everything is controlled by the dwellers. The only inconvenience is that the better the weather is, the heftier bill you're going to get next month. The UV protection is essential on Ross 128b. Its index is 38% higher than on Earth, so a regular sunscreen turns out pretty helpless. They say this planet is like the Earth twin, but you kind of disagree. There's some vegetation, but it all looks so weird, you feel like you're in a computer game. Next to the apartment block, there's an orchard and a small farm producing organic food for the locals, so you decide to pop in and check how it works. The fruits and vegetables look so odd there. You realize this must be an apple tree, but it has microchips instead of flower buds, and the fruit are cubical. There are apples of all of the rainbow colors. You go forward and stumble on a small rock, one of the few things that belonged to this planet originally and weren't imported from Earth. A butterfly lands on the tip of your nose. You want to touch it, but as soon as your fingers reach it, the insect disperses in numerous pixels. The real estate agent runs up to you, helping you stand back on your feet. She says all the fauna on the planet is still represented in a form of holograms, because transferring it all from Earth doesn't seem possible at the moment. All the fauna elements are tightly connected together, and even the smallest butterfly can make a dramatic difference. With the money you have for the down payment on Earth, you can afford a 2-story apartment on this planet. The only problem is tiring commuting to work every single day. Come on, y'all, Mars is ahead. We still have a lot of apartment blocks to show you. Ah, that's the real estate agent calling you. You hop on that bus and sometime later you land on Mars. By $29.99, it looks just spectacular, but a bit too sandy. The scientists still can't bring liquid water to this planet, even though the atmosphere is completely fine. The planet's too warm now because they tried to make it habitable. Even though there are glaciers, all the water instantly turns to gas because of the heat. You spot some large machines up in the sky. The real estate agent says these are some essential pieces of equipment that trap the gas water up in the sky to make Martian pouched water. She hands one pouch to you to try it out. Looks like an air balloon. Weird. You inhale it and you've never tasted anything like this before, and you still can't understand how that gas quenched your thirst. The main plants on Mars are cacti of all forms. They adapted perfectly to its atmosphere, and scientists even managed to blend other plant genes with those of cacti. These tall plants are a Martian type of maple. You can tell it looking at the leaves. Here, there are some pears growing on that large cactus, and you can see mangoes, avocados, and fruits of all kinds. They seem to be thriving. The sun's shining, and they're surrounded by water in the form of gas. It almost feels like home here. While Ross 128b still has to be developed, it's been over 200 years since the first ranch on Mars was made. The real estate is pricier here though, so you can only afford a nice studio apartment. Looks like a bargain, but it's time to visit another planet. You're headed to Europa, one of Jupiter's moons. You've been to this planet last year on vacation, and you loved it a lot. 1,000 years ago, the scientists thought there was water under its icy crust, and they were right. The crust melted, forming a huge ocean twice the size of Earth's world ocean, and the planet itself has been undergoing various changes over the last millennium. All the cracks it had on its smooth surface form many small continents. All of them were named after European countries, but you have enough time to visit only one of them, Italy. The continent is surrounded by azure water, and there are endless fragrant lemon trees. People cook pizza with freshly grown tomatoes, though they're as large as Earth's watermelons. One tomato is enough for 2 pizzas. You look through the Europa brochure to get more information about other continents. On Norway, there are mountains looking very much like Norwegian fjords. On France, there are endless lavender fields. And on the continent of Greece, there are large farms with olive trees. You close the brochure, realizing that real estate here is almost as pricey as back on Earth. No wonder too many people want to live there. Time's up, you've got one more planet ahead. The bus is about to land and there's an announcement. Welcome to Saturn. Put on your swimming masks and dive in to see our ultimate apartment block. The scientists spent over 250 years trying to solidify Saturn, but it was in vain. In the end, they decided to try making the first settlements back in the 2980s when you were a kid. The gravity on Saturn is a bit stronger than on Earth, which allowed scientists to construct large complexes under domes for people to dwell there. In the depths of Saturn's gas oceans, there's a wide variety of fauna – jellyfish, octopuses, even sharks. They look a bit different, trying to adapt to their life on another planet. Their fins look way larger to help them handle incredibly strong winds of 1,100 miles an hour. But the most incredible part is the flora. Saturn's algae come in at least 3,000 different colors. At least the brochure says so. You can also regulate their intensity and shade with a remote. 2 hours later, you're back in your capsule. You keep tossing in your bed. It's the last night here. Tomorrow is the big day, but you're still in two minds. You saw that studio apartment on Mars in your dreams. You ate Martian pancakes topped with cactus maple syrup. The alarm goes off. Congratulations! You're now the owner of your own apartment on Earth. Very few people can make it in $29.99, Mr. Sanders. You're holding a set of keys in your hand. A notification beeps on your phone. Lease your apartment on Earth and move to Mars. You won't ever have to work again. You can't help it and begin to smile. In the near future, people have made the greatest space discovery in history. The entire population of Earth looks up to the sky to see the greatest astronomical show ever. Is this real? What does it mean? Scientists have been studying galaxies, planets, and black holes millions of light years away. But all this time, something fantastic has been hiding in plain sight right above our eyes, on the moon. Starting a few years ago, humans began going to the moon again, and finally set up a permanent base there. While excavating the lunar landscape, one lucky drill smashed into something like a metal plate. It turns out that metal contains polycarbonate, aluminum, gold, and silver. That's very similar to something humans already have on Earth. It's basically what CDs are made out of. People start going excavation crazy. Who knows what else is down there? The moon turns out to be our greatest resource. After a few months, lunar construction equipment has excavated several hundred feet of the shiny surface. At first, it was kept quiet, but a year later, that becomes impossible. Excavation crews dig out a huge rectangular shiny piece, the size of 10 football fields. And that plate is not alone. There are literally millions of them. After a little more research, scientists discover that the entire surface is covered with this strange material. People gaze up every night at the unusual moon in the starry sky. It glows a little brighter than before. You only need the most ordinary telescope to see that things are about to get weird. The excavation work isn't complete, but scientists have concluded that the moon is a huge disco ball. Who created it? For what? And what does this mean for us humans? No one has any answers. Soon, humans managed to dig up more than half of the moon. In some places, the plates are too deep to get to. They're stuck under mountains. In other places, the plates of the disco ball lie directly under the surface. Somehow, even with this crazy discovery, the properties of the moon haven't changed in any way, except that it's become brighter. Attempts to dig deeper, to pierce through the plates, are hopeless. The layer of polycarbonate and metal alloys is too thick and seems to go deep into the core of the moon. Some scientists suggest that if the moon's surface resembles a CD, it might just mean that there's some information recorded on it. That would change the course of history. They decide to build a laser reader to see if the moon really is a whopping big CD. Meanwhile, the drilling continues. On the dark side of the moon, which isn't always dark by the way, people find a small crater. Surprisingly, there's no shiny material inside. This perfectly round hole looks like a dried-up lake. At first, everyone assumes that there was a plate there. It just must have flown off somehow. But then, why was that crater so perfectly round? After a little more investigation, diggers find something that looks like plastic. What's that all about? Then, unexpectedly, the digging stops. The huge rig smashes against a thick alloy of unique durable plastic. There's a perfectly round plastic disc hiding inside the crater, the only one on the entire moon. It becomes clear that this huge disco ball was created by something billions of years ago. It's been covered with cosmic dust ever since. IT specialists scan the entire lunar surface with the help of satellites. They find something. It looks like there's a complex electronic system hidden under the disk. If you look at the moon as a whole, the crater starts to look an awful lot like, well, a button. Time to press play on the moon. To understand what's going on there, scientists try and try to get through the plastic layer. While they're doing that, there's an accident. An automatic drill explodes under insane pressure. The blast is so strong that it activates the button. All of humanity freezes in fear. There's silence, real silence. Then, it happens. The moon starts to rotate ever so slowly on its axis. Then, hour after hour, it rotates faster and faster. There's a mad rush to get everyone off the moon. Soon, it'll be spinning too fast to take off from safely. A lot of people fly halfway across the planet, where it's night, to see what's up with the moon. Every TV channel, website, blog, vlog, live stream, everyone's broadcasting the same images, those of the great disco ball in the sky. The moon begins to spin so fast that all the loose rock and sand on its surface gets scattered in different directions. Some lunar fragments fall on Earth and create an incredible meteor shower. The moon is spinning faster and faster. Now it looks like a real disco ball. The night sky is lit up with bright rays of white. It's incredible. People are ecstatic, amazed, delighted. But a moment later, all of humanity descends into a deep state of fear. Astronomers report that the moon is approaching Earth. When it gets too close, Earth's gravity will destroy it, and the giant crushed-up disco ball will smash into our planet. Every hour, the moon gets bigger in the night sky. Floods are starting to break out all over the world. People dust off their underground bunkers and get inside. There's no time to blast the moon with a rocket or anything like that. This could be it. The moon creeps closer and closer to the Earth's atmosphere. Then it stops, and nothing happens. Incredible! The disco ball isn't affected by our planet's gravity. Some sort of ancient technology inside the moon just saved us from disaster. Then, a deafening sound booms out from the night sky. It's coming from the disco ball. The sound wave obliterates all the clouds in the sky. It sounds like a roar, a deafening bass that makes the ground shake. It's intimidating, scary, but then a rhythm starts to come out from the wall of sound. Impossible! There's music coming right out of the moon. Then some plates start to change color. They turn purple, pink, blue, green. It looks wild. The different color rays dance around on the Earth's surface. It gives everyone an insane energy boost. Everyone wants to be outside with friends, neighbors, anyone. One moment, you're standing under a green glow, and a second later, everything around you gets lit up in pink. The incredible light show creates an unbelievable desire to dance. DJs around the world team up to record a whole new sound that mixes with the moon's music. They call it MLB, the Moon Light Beat. People all over the world go out into the streets and kick off the biggest party ever. Scientists now think that billions of years ago, our planet was inhabited by huge intelligent beings the size of Mount Everest. They wanted a party and set about creating a huge disco ball. Then these creatures moved on to another planet. Earth was getting kind of cramped, and the disco ball was simply forgotten. Over millions of years, dust and rock obscured it from view. For several months, the moon continues to spin, and DJs keep pumping out music. People start to get a bit tired of the whole thing. They want a bit of silence and a calm, starry sky, not a glittering moon disco ball. Humanity starts experiencing mass insomnia and dizziness. All flights are grounded because the bright-colored flashes make it impossible for pilots to see properly. Unfortunately, no one knows how to turn this thing off, and it's impossible to study because the moon's moving around too fast. The problem is solved by itself. The ball stops and returns to its orbit. It's possible that it just ran out of battery. People aren't exactly in a rush to reactivate it, but they leave detailed instructions for their descendants in case they want to throw a global party. It's the year 2600, and the New Frontiers program has finally begun. You've got the list of planets to plan dwellings for, and the first one is Venus. The Earth's evil twin sister meets you with a refreshing 800 degrees Fahrenheit and a beautiful sulfuric acid rainstorm. First of all, the heat means living on the surface here is next to impossible, so you immediately put the prospective house several dozen feet underground. The walls, floor, and ceiling must be made of some heat-resistant and durable material, so you make them out of hafnium carbide. Discovered way back in 2016, it withstands temperatures of over 7,000 degrees. Next, you install the air cooling and purification system. It captures the toxic air from the Venusian atmosphere and pulls it through a complex network of filters, delivering breathable air to the dwelling. As an added benefit, the temperature of this air can be easily turned up thanks to what's going on outside. You can create a separate room below the main space and dub it the generator room. The device there will use the almost infinite geothermal energy of the planet to provide the house with electricity. You think for a moment and add a geothermal bathroom as well. There's no water on Venus, but it can be extracted and separated from its acidic clouds. The piping system would include a heating unit for hot water and a cooling unit with liquid nitrogen for cold water. Another separate space is the garden. Since no plants can survive on the surface, you create a spacious hall with bright lights on the ceiling and a sprinkler system throughout the area. You have large patches of soil for vegetables, several acres for fruit plants, and a big patch in the center for a couple of long-living trees like oaks. They'll provide additional oxygen for the whole building. The garden is encased in a shell of hafnium carbide as well, so that the plants don't wilt in the excess heat of the Venusian soil. You check if everything's accounted for and go to your next stop. Saturn. It's a gas planet, but there's a thin yet stable layer that can be called the sweet spot. Its temperature is just right for humans to feel fine. You create a hover platform to build your house on. There's just no solid ground on Saturn at all. The platform's equipped with wind-powered turbines. The winds on the gas giant reach incredible speeds, so it will need to counteract them, at the same time feeding from the hurricanes. The pressure and temperature are just about right in this place, so your main concern is the wind again. You make the dwelling low and looking almost like a frisbee for better aerodynamics. The walls and roof are made from a single slab of sturdy metal, so that powerful gusts can't tear the roof away. You also make them several feet thick and add some windows with space-grade glass panes that won't break. Water can be extracted from another layer using a series of similar platforms with built-in pipes. Electricity and heat are no problem either, thanks to the powerful winds. The only problem here is food, but it can be imported from other inhabited planets at first, along with the fertile soil for the garden. You create a space for it on another hover platform for the future. Satisfied with your results, you head to the next destination on your list, Europa. This moon of Jupiter's is covered in a miles-thick crust of ice full of canyons and crevices. But deep below, there's a whole ocean of salt water bigger than all the oceans on old Earth taken together. You take it into account and go for an underground dwelling again. The temperature is freezing, but the closer you are to the hot planetary core, the warmer it is. You place the dwelling as deep as you can to safely extract water from the underground ocean. The walls and ceiling are padded with insulation, and in the cellar, there's a home water purification system that turns salty water into the potable kind. Since there's no atmosphere to speak of, the breathable air is extracted from the ice. As it melts, the water vapor is collected and filtered, then enriched with other necessary substances and delivered to the dwelling. As for food, you go for an unusual solution: edible marine plants and fish. You create a separate tank to cultivate algae right in the ocean, and different kinds of fish can be imported from old Earth and other inhabited planets to breed on Europa. Next stop, Pluto. The tiny dwarf planet, just 1/6 of old Earth in width, has a great potential for terraforming. So you immediately create a big dome for your dwelling. The sun shines much weaker here than in any other place in the solar system, so you make sunlight-enhancing panels all across the dome. They'll allow the surface underneath to receive more light and warmth, bringing the area to a comfortable temperature. The ice on Pluto consists of frozen water, just like on Earth, so you build a station for melting it and collecting the resulting liquid into large tanks for later use. There's also a possible liquid ocean deep under the surface, so you add a deep drilling platform, but put a question mark on it. You don't know if it's going to be useful yet. With the area warmed up and well lit, you make a pretty ordinary dwelling like ones we're used to on old Earth and terraformed Mars. A couple of stories, carbon or titanium alloyed walls and ceiling for durability, and a fortified cellar. Still, you also add emergency insulation padding that will only trigger if something happens to the lighting dome. If it's breached, the temperature will quickly drop to below freezing. There's also very little atmosphere on Pluto, so breathable air will have to be generated from the ice again. This time, you combine the water collecting system with the air generating facility. While one produces potable water, the other will collect vapor and enhance it with all the necessary elements. You even go as far as to create a weather controlling device. It will heat up or cool down different layers of the produced air and mix them together to create winds and rain clouds just like on old Earth. This will allow crops to grow in a more natural environment, and Pluto might even become a green planet one day. Right above, in the dark blue sky, Pluto's biggest moon, Charon, is hanging. It's half the dwarf planet in size, which makes it a spectacular view. Its climate is almost identical to that of Pluto's. In a fit of inspiration, you create a vacation home for Plutonians. Here, under a similar dome, they'll be able to explore another little world and look at their dwarf planet from the other side. Which is always the same side, by the way, like the Earth's moon, which reminds you of the next destination. Zarmina, previously known as Gliese 581g, is 41 light-years away, the longest trip so far. The planet's tidally locked to its sun, which means there's perpetual day on its one side and eternal night on the other. It's not only about light, but heat as well. The day side is much hotter, and the night side is partially covered in ice. Unless we terraform the planet, the most comfortable area to inhabit is right between the two sides, called the Terminator Zone. It's neither too hot nor too cold here, and there's an eternal twilight. The sun is always just above the horizon. The good news is that the atmosphere on Zarmina, although volatile, is rather close to the old Earth's, but you still cover the selected area with a protective dome just in case. Human dwellings here don't have to be specially protected from the elements, and there's liquid water too. You build a pretty generic house, much like the one on Pluto, but then add a few crucial details. First, the weather controlling device. Despite the old Earth-like atmosphere, dwellers will need a stable change of weather to grow crops. Then you cover the dome with moving plates. Living in a constant dust might be pretty depressing, so the plates will move in 12-hour patterns. During the daytime, they will turn to enhance the sunlight, while at night, they'll deflect it back, making the sky dark. After that, you travel to both edges of the Terminator Zone and install geothermal plants. On the hot side, the plant will generate energy for all the settlers' needs and take hot water to use in households. On the cold side, the system will make cold water from the ice. The night side can also be used as a giant refrigerator. Dwellers could store things they need frozen here. To make it easier to access, you stretch the dome from edge to edge and create some simple storage facilities where the night begins in earnest. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if